Hello, welcome again to another exciting time. Today we are going to be talking about actuarial notation. That's the actuarial notations we have. Now, when we understand this actuarial notation, it helps us to be able to understand everything we are going to do in life contingencies because that's actually the introductory part of it, knowing all the notations that we have. So before I'm going to talk about these notations, I'm going to talk about probability. So what does probability means? Now for short, okay, I'm going to have this probability. So that means the number of required outcome over the number of possible outcomes. So let's say, for example, we have a die and we are going to throw the die once. So what's the probability that what we are going to have is going to be, the number that we're going to have is going to be an even number. So we have a die, and a die is actually having 6 surfaces. And these surfaces are numbered 1, 2, 3, 4, 5, and 6. So when I throw a die once, what's the probability that the number that I'm going to get is going to be an even number? So going back to this formula now, the probability of getting an even number when I throw a die once, what's the required outcome? An even number. That's the required outcome is an even number. How many even numbers do I have on a die? I have 2, I have 4, and 6. So you can see there are 3 even number on a die. So the number of required outcome, which is the number of the even numbers we have on a die, is 3. So I'm going to say the probability that I'm going to have an even number when I throw a die, that will be 3 because I have the number of the even numbers that I have, we have 3 of them. Now, how many numbers do I have in total that were represented for the exercise? We have 1, 2, 3, 4, 5, 6. So I have a total of 6 numbers, which when I reduce this fraction, it gives me 1 over 2. Now, this is quite clear. Probability always take numbers from 0 to 1. As probability, it takes numbers from 0 to 1. So I have 0 to 1. When it is 0, it means that the event will not occur. Then when it is 1, then the probability of it occurring, when we say the probability of it occurring is 1, that means it is sure to occur. So probability takes numbers from 0 to 1. So you can see 1 over 2. So the probability of having an even number when I throw a die is 1 over 2, which is actually between, what do you call it now? 0 to 1. So 0 less than or equal to p less than or equal to 1. So let's say P is the probability of an event occurring. P for short is the probability of an event, an event occurring. P is the probability of an event occurring. Then what's the probability of it not occurring? Since we said that probability takes numbers from 0 to 1, so if 1 over 2 is the probability of having an even number, then what is the probability of not having an even number? Now you have to know that the probability of an event occurring, so we are going to say Q is the probability of it not occurring, probability of not occurring. So now if P is the probability of an event occurring and Q is the probability of it not occurring, when we add that up together, it should give us 1. That's to say, when we add the probability of it occurring plus the probability of it not occurring, it should give a total of 1. Now this forms a bedrock of life contingencies because we are looking at the probability of survival, the probability of dying. That is exactly what we are looking at. So I believe that this is quite clear. So if I said P is the probability of an event occurring, then Q is going to be 1 minus P. That's 1 minus P of it not occurring. So I'm going to quickly go into this notation. This is just a recap a quick recap of probability. So first, what do you need to know whenever we're talking about the actuarial notation? So let's see this. What does this mean? It means a life age X. A life aged X. That is what it means. So when we put it in this curved bracket, it means a life age S. That is what this notation means. Now, let me give you an example. Let's say in the year 1982, Nigeria recorded 10,000 births all across the country, spread around. We have 10,000 births in 1982. Now, logically, in the next 8 years, those births that we have in 1982, in the next 8 years, if they are still alive, they will all be 8 years old if they are still alive. So you won't find in that particular group, let's say they were all given birth to in 1982, and then in when we add 8 to that, and that gives us like 1990. In the year 1990, you'll find some of them are 10 years old, some of them are 12 years old, some are 7 years old. No, that will not be the case. So if they are still alive, it means in 1990 they will all be 8 years old. Why? Because they were given birth to in 1982. Now, those births or those individuals that we have that were given birth to in 1982, we actually group them. They have something in common, the same birth year. So we can call that a cohort. A cohort, they have something in common, which is their birth year. So let's say, for example, in 1982, we had 10,000 births. So this notation, LX, simply means the number of lives that are X years old, the number of lives that are X years old. So in 1982, they were all less than 1 years old. So we can just denote that with 0. So it means L naught is 10,000. Now, in the next 3 years, they will all be 3 years old. So we can call that L3. So it means in that cohort, we are talking about that cohort, they are all 3 years old. So L3, what is the number? Of course, we might lose some might die, and some still be alive. So we don't expect that L3 will be more than L naught, right? Usually, as it keeps increasing, it means it's going to keep getting smaller because we'll have some that would have died already. So L3 will be less than L naught. And so it goes that way. We can have L10. L10 will be less than L3. L3 will be less than N naught. So in this case, at the beginning, they were all 0 years old. We have 10,000. When they were all 10 years old, of course, the number is going to reduce due to the death that might have occurred in that particular year. So I believe that this is quite clear. So we call LX, that's the number of lives aged X, the number of lives aged X. Now, the next thing we're going to look at is going to be the probability. What's the probability that someone who is X years old will survive after a year, will survive after a year, or will survive in the next 1 year? So what's the notation for that? We have P subscript X, and then we survive. A life age X will survive 1 year after. So what is the probability? But then in actuarial notation, since it's going to be 1, we don't usually put the 1 there. So whenever we see something like this, it is assumed that this means in life, of a life, the probability of a life age X surviving, surviving, surviving in the next 1 year. So that's what we have, P subscript X. But anything greater than 1, we actually denote it with N. Well, it's not like generally acceptable, but well, for most authors, we always make use of N. So I'm going to say P subscript X, and then behind here, subscript N. So what does this simply mean? It means that the probability of a life aged X surviving surviving in the next n years. Surviving in the next n years. Now, this is very important. But then let's talk about this a little. And let's say we have the number of those who are alive at age, let's say 10. So we're picking this up now. Remember, in 1982, we had L naught, which is 10,000 birth. They were all 0 years old as at that time. That is less than 1. And we have 10,000 of them. So we've established that in the next 8 years, this 10,000 would have reduced because we'll have some that might have died as at that time. So now let's say, what's the probability that a life age, let's say 8, will survive in the next 3 years? A life age X will survive 8, will survive in the next 3 years. So we are going to look at how many lives do we have that are 8 years. That is talking about L8. How many lives do we have that are 8 years? And the next thing we are going to look at, how many lives in the next 3 years, which this L8 will become L11. That is 8 plus 3. So, of course, we know that L8 is greater than L11 because when we have L11, certainly the number would have that. It could be the same. So I can say L8 is less than or equal to, sorry, L8 is greater than or equal to, let me just put the L, okay, L11 is less than or equal to L8 this way. So if L11 is equal to L8, it means no death were recorded in this cohort, just like the number we have that are alive when they were all 8 years old, the same number we have when they were all 11 years old. That particular cohort, they were all giving birth to the same year. They were all giving birth to the same year. So L11 is less than or equal to L8. But then most times we don't really have that case. So let's say L8 is less than L11 is less than L8. So what's the probability that a life age 8 will survive in the next 3 years? So back to probability, the number of required outcome. What's the required outcome? We want to know those who are alive at L11. So now the first thing is, how many do we have that are alive at L11? Because that's the number of required outcome. So P83, this will give us L11 over how many were alive when they were L8. So that's over L8. It's just quite a simple illustration. So what does that simply mean? It means that we have the probability of a life age X surviving in the next n years is going to be Lx plus n over Lx. Now, you don't need to be confused with this because certainly Lx is greater than Lx plus n. Remember that what does this Sn means? It means the number of years has already increased. And of course, as the number of years increases, then the number of people who are alive in this cohort is certainly going to reduce due to the recorded death that we have. Now, just like what we have in probability, we said if P is the probability of an event occurring, then Q, which is going to be 1 minus P, is the probability of it not occurring. So we can be able to relate that to this. So let's say QX. Now, of course, QX, if we put 1 here, what does it simply mean? It means the probability of a life age X not surviving beyond 1 year. Not surviving beyond 1 year. So this is the probability of a life. I can put it this way. The probability of this not surviving beyond 1 year. So that's it. So this is the probability of a life age X not surviving beyond 1 year. And that's what it means. But then, as I said, based on standard actuarial notation, if it's going to be 1 year, we don't actually put that in here. But anything greater than 1 will certainly capture that. L subscript X N. So what does this simply mean? the probability of a life age X not surviving beyond n years. So that's exactly what we have here. Now, you can see this, putting this in this box here helps us to remember this. So it's very important for you to bear this in mind. P sub root xn equal to Lxn over Lx. So let's see how we're going to get the others. Okay, the other notations. So we have this, that is q x n. So remember I said this will be same as 1 minus p x n. And then we have that p x n is equal to this. So I'm going to say 1 minus lx plus n over lx, which gives, this is for 1, I'm going to have lx minus lx plus n all over lx. So that's what I'm going to have. So I have qxn. So again, I have another notation here, and then a formula that I was able to derive. So I have qxn equal to, this will be over here, as lx minus lx plus n. Don't forget that lx is always greater than or equal to lx plus n. Yes, of course. So this is not going to be negative. The number of lives that are alive X, and then the number of lives that will be alive in the next n years. That is this particular lives that we have here. And how many of them? Of course, it's going to reduce. So Lx is greater than or equal to Lx plus n. So we have something like this. So this is a very important notation, just as this. And then we have this also. Again, we want to know how many deaths occurred. Yes, we want to know how many deaths occurred. Okay, when they were all X years old. And now, in the next n years, they were X plus n years old. This group here, when they were X years old, in the next n years, they were X plus n years. So we want to know how many deaths occur. Of course, to get the number of deaths, we denote that with dx. So that simply means how many were alive. Yeah, Lx. How many are alive here now? We have that minus Lx plus n. So this is logical. It's logical to have this. So that this dx means the number of deaths. That's the number of those who are X years old. How many, that's the number, those who are X years old, how many of them died between when we have this number Lx and then when we have this number Lx plus n. So remember, Lx is greater than Lx plus n. So this simply tells us the number of deaths. So I'm going to say the number of deaths that occurred in this cohort, the number of deaths that occur in this cohort. Cohort, I mean all those individuals that were given birth to in this particular here, they form a particular group. So the number of deaths that occur, that is what we have here. Now we can be able to relate this with this. You can see that we have something like this, Lx minus Lx plus n. So I can simply say Qxn is same as dx over Lx. Again, this is a very important notation that you need to know. So when you have an understanding of it, yeah, it's quite easy to see it play, right? So we have the probability here surviving, the probability here of dying, the number of deaths here, and then we're able to relate that to what we have here. Now, the last thing I'm going to talk about in this video is going to be, let's say for example, okay, let me just put that down first before I say anything about that. So what does this simply mean? Q, X, M, and then this. Now remember, all these are subscripts. What this simply means is that the probability of a life age X surviving in the next M years, but then dying or not living, not surviving beyond N years. Let me say that again. This is the probability of a life age X surviving the next M years, So let's say a life that is, let's say 8 years old, then surviving the next 3 years, but then dying after that, not living beyond 2 years. So that's why we have something like this, just a vertical line. So the probability of a life age age 8, surviving the next 3 years, but dying between these three to that 2 years that we actually have. So that's what this notation is talking about. So how can I represent it as a probability? First, I have to know that this life age X survive in the next n years. So based on probability, I'm going to say the probability of this life age X surviving in the next n years. And then this same life now, since the life survived to m years, it means the current age will now be what? X plus m. That's the current age. But then the life did not survive beyond n years. So I'm going to say q x plus m not surviving beyond n years. So that's exactly what I have. So I can say that this, from the interpretation, I'm able to derive this, that this is a probability of a life age X surviving the next n years but dying in the next 2 years, or not surviving again beyond this n years. So sorry, I'm picking up the two here. Not surviving beyond these n years. So we have something like this. We can as well relate it to the others. It helps a lot to be able to do that. We have, so remember that we have said we know what this means, Pxm, which is same as Lx plus m over Lx, right? And then I have this. We have Qx plus mn, that is to say 1 minus Px plus m. And then we have n here. So there's just a way we can play around it entirely